until we came along at Moe and said, hey, we can use cameras and give you analytic data that the industrial engineer would only capture when he was there and only capture it mechanically by starting and stopping a watch and visually what he could see. You put the camera there and we'll give you the data that's going to improve your decision making, that's going to give you more throughput and more efficiency in the factory floor.
Very great to have you on this podcast. Appreciate your time. And I think we're going to have a very interesting conversation about your experience, your expertise, and your thoughts about the future. So, welcome.
Thank you.
So I'd like to, I was told that you grew up in Allen Park early in your life, and I'm really interested to understand, how were your early years growing up in the manufacturing industry in the Detroit area. Maybe we could start there, and then we
Okay.
could go from there.
All right. Um, it's kind of interesting. I grew up in a very blue collar area of Detroit, and I always consider myself now one of the few auto guys that was actually born in the city of Detroit. I was born on Ford Street in Detroit, and that's
Mhm.
kind of unusual now to be an auto guy and actually come from the area. But I went to a relatively modest high school and didn't know much about engineering, but I thought I had a gift for math, and I ended up scoring high in math area and ended up getting into advanced program, and I was kind of proud of that. And so when I ended up getting to college, I looked at what jobs math majors had, and that wasn't very good. So then I looked at, hey, there's a lot of math involved in engineering, and there were a lot of people in engineering that were failing what I would consider one of the tougher courses for an engineer, differential equations. We called it diff EQs. And because I was good in math, I was able to get through that, and that put me in engineering school. So
Mhm.
I didn't know much about engineering still at that point. And then I graduated as an engineer and decided that I'd put in applications. And so I put in applications to various spots. And I was driving back. In fact, McLeod Steel was one where I put in an application, and they had called me in for an interview. And if you knew anything about the steel industry, McLeod was the first. They have an electric furnace, and that's what most scrap metal today goes through, are electric furnaces. And it was located in south of Detroit in a city called Wyandotte. So I came down here, and it was one of the few times in my life I had a suit on. And I was driving back to college, and I was driving by the Ford headquarters and said, well, while I got a suit, and I have some resumes in the back seat, I just go in and put one in, walk in and put one in. And so I did that. And by the time I got back to school, my mother called and said, hey, Ford Motor Company just called you. I want you to come back for an interview. So I did that, and I ended up in the interview was in the Rouge area and in a factory. Well, Ford made me an offer. McLeod Steel made me an offer, and life is interesting because they'll tell you the exact numbers, and everyone will laugh. I mean, McLeod Steel offered me 900 a month, and Ford offered me 850, and I laid awake the entire night over that $50 and what offer to take. And I called everybody I knew, and of course, I didn't know anybody that had a lot of experience because of my upbringing, and everybody was struggling with the $50 too. So finally, I said, "Well, I'll take the Ford offer." So I went in, and it was a job as an engineer in manufacturing. Okay, in a glass facility in the middle of the Rouge area, and that was in 1972. So 70, if you probably don't remember, but we had a recession in 74. So I'm kind of enjoying this, and I'm learning some things about the manufacturing area while I'm working as an engineer, a floor engineer. And next thing you know, we're having our first recession, and Ford demands, I think it was a 20% layoff. And I'm thinking, oh no, I'm going to get laid off. And sure as hell, I get a call from the plant manager who, I mean, that was a big deal then. why is the plant manager calling me? And he asked me to come up to the office. And so I assumed this was the end. So I ran up to the plant manager's office. I can remember this like yesterday. I sat down across from him. I was so impressed to be in an office this size, even though we're in the middle of the Rouge area. And he said, hey, here's the situation. We got to lay off a lot of people, and I don't want to lose you. So if you accept the job as a floor supervisor for a year, we'll keep you. And when this passes, you'll go back into engineering. So once again, I thought, oh man, I have another major decision. How am I going to struggle with this? So I go home, I don't sleep again. I asked my wife what to do, and she looked at me and said, do you have another job? And I said, no. She goes, well, then I think you ought to be a floor supervisor. So I really didn't want to do it, but it turned out to be the most important thing I probably did in my career, because I learned so much about the factory floor. I learned so much about people, and I learned so much about productivity and throughput. Later in my career, I came back as the plant manager of that very plant. And some of the same people that I supervised, hourly people as a floor supervisor, were still there. And that relationship and that understanding gave me an advantage, I think, not only for the rest of my career, but particularly when I came back as plant manager of that particular facility. So from that point, I always considered myself to have some inside expertise in factory floor engineering and throughput and productivity. So it's a long answer to your question. That's kind of how I got to where I was. And later, I ended up with another kind of big break. And that is that Ford would send one engineer every year to MIT. And I didn't know much about the program. And I kind of got a call out of the clear blue sky that I was asked to go. And once again, I said, I don't want to move to Boston for a year and drag my family and do all this. So I went home, asked my wife again, hey, she goes, you kidding me? Let's do it. So I did that. And I always felt those two things, working on the floor as a foreman or supervisor, and having the MIT experience in business management, it was a Sloan School, were the two things I think that gave me the best insight I could have in my career.
Oh, that's great. I mean, it's a very thought-provoking story, right? I mean, if you think about it, manufacturing floor experience is so crucial for manufacturing, any manufacturing job. I mean, especially if you're in engineering or in management, if you haven't walked the floor, it's a big disadvantage. And those things came your way, and that's and thankfully your wife gave you the right direction.
I think so. Yeah.
You have her to thank for. So
Yeah.
that's great. So this is so you grew up in Detroit. You had all these opportunities. You obviously developed interest in cars, right? So talk a little bit about your interest in cars. How did that come about
Well,
during?
that's an interesting story too. My father was very good in repairing cars, and some of it was a necessity. And I think back on it because we couldn't afford to take the car to a dealership or a garage, and so we had to repair them ourselves. And so I would help him, and he taught me a lot about vehicle repair. Of course, the vehicle was simpler then and so forth than it is today. But and when I was in high school, one of the things our high school had, because most of the people that left my high school ended up in blue collar type environments, was an auto shop class. And so he forced me to take auto shop. I wasn't going to sign up for it. And he said, no, you got to take auto shop. You got to understand that. And the instructor was very good and really taught you the parts of the car and how the car worked. And of course, these were the days where you had distributor and you had points, and the wiring was extremely simple. And so I learned a lot about how to repair cars, and from that I had a pretty good advantage when I went to Ford about how cars work. And I had an interest always early before a Ford career in a Barracuda, and I own that very car today. Okay, and It's a 1964 and a half. It's the first year that Chrysler had the Barracuda, and there was a race between Mustang and the Barracuda. One built on a Valiant and the other built on a Falcon. And of course, the Barracuda won by 2 weeks, but the Mustang obviously was much more successful. But I knew every part in that car. And so when I found that car, I decided, well, I'm going to buy that car just for the fun of having a classic. And then later, when I went to Dura and ran Dura, there was a lot of opportunity for us to place special parts on sports cars. And when Dura got the job to put a part on a sports car, I was always interested to drive that car and usually ended up buying it. I have a bad habit where if I buy something, I never seem to sell it. So now I ended up with 7 cars because we had some unique parts. Dura had some unique parts on all these vehicles, and in all those vehicles, now we're sitting in my garage. So I had to build a new garage, have the cars in there. And unfortunately today, I could, on most of those cars, they're simple enough where I could, not all of them, I could still do the repair. I can't do the repair on a Porsche or an Audi R8, but I can still do the, whether I physically can climb under the car and do those kind of things anymore at 75, probably not. So I probably now source more outside than I do myself inside. But from that, I always consider myself a car guy. I actually had the opportunity to race some cars at times. I don't do that much anymore at 75. And at Dura, one of the products we made is we call it an MTX shifter. It's a manual shifter, what's probably known today as a millennial anti-theft device, because not many people can drive a manual car in it. But most of my cars have manual shifters with push-pull cables, and I still enjoy that. So that kind of put me in, I think, a classification. And I found that also to be an advantage because a lot of engineers today that work for the auto company, my opinion, don't have that drive and love of the car. So there's not a lot of people, mostly older people, I think, that have a real passion to drive unique type of vehicles.
Yeah, it's that is true. I mean, the cars were simpler back then, and you could actually take apart cars, especially if you worked in the plant floor, seeing how they were put together.
Yeah,
But today, I think there's a lot more technology in the car that kind of abstracts the whole concept. It's
right.
like it's all ones and zeros now, unfortunately. So yeah, it's well, maybe that's the reason, or maybe not. Not sure, but I agree with you. The kind of love for cars and the mechanicals of it is kind of mostly old school now. Although I do see people here and there get involved with it. Um, just shifting to operations management, right? So
Yeah,
I know you kind of worked on the plant floor and you were a supervisor and then moved up from there. Can you talk a little bit about your experience in the plant floor itself and how you got into
yeah.
operations
You
management?
know,
Yeah.
in preparation, get back up to this interview. I put some thought into this, and this is knowing what we do here at Moe, okay, and uh, knowing, and I still do. I'm on the Moe board, obviously, but I still do other board works. I'm on 3 other boards, and I just had the experience yesterday to walk the floor on a stamping company that I've been on the board now for about 5 years. I won't give you the name. I was thinking about the throughput and some of the things that we do, and one of the things that all of a sudden struck me was when I started, we used to have what was called industrial engineers. And an industrial engineer, he would have a clipboard and a stopwatch on top of the clipboard. And he'd go out there and he'd measure various elements of waste and productivity. And that discipline has evolved and gone. And it's really, now that I thought about it, hadn't been replaced in any one way until we came along at Moe and said, hey, we can use cameras and give you analytic data that the industrial engineer would only capture when he was there and only capture it mechanically by starting and stopping a watch and visually what he could see. If you think about what Moe can do, we can capture that type of analytical data 100% of the time, okay, in 100% of the locations. Something that you would have to man the floor from when I started with with 100 industrial engineers. And now the productivity to be able to do that type of engineering analysis with data. Yesterday, I focused in a bottleneck area that they thought was creating issues with the customer at where I was walking to the floor, and it happened to be the shipping department. And the initial reaction, and I was remembering back in the auto plants I ran 3 auto plants. And the auto plants I ran, all the time, the guys would come in and go, "Hey, boss, the deal here, we don't have enough shipping docks. We need more shipping docks." They always wanted to add shipping docks. It didn't matter. I had one facility. We had 13 shipping docks, and that wasn't enough for them. It wasn't enough. That's clearly the thing, boss. If you give me $100,000 and I'll build a new shipping dock and my problems will go away. Well, yesterday, the CEO of the business says to me, "We don't have good people in shipping." And I thought, well, that might be true, but how do you know you don't have good people in shipping? Well, it's a problem. It's a problem area. And I said, "Hey, do you have data? Do you have data in shipping? How long is the truck there? Was the material staged properly? Do we have trucks in the parking lot that are sitting in queues? Are the docks empty? What percent of the time?" And there's no analytical data. And the shocking thing was when I walked out with the manager of production to the shipping dock area, I noticed there were cameras. They were there, I think, for security, not to measure analytical data that could be used to see exactly how we can improve the throughput of the shipping area. So when I went back in and got the CEO aside, I said, "Hey, I noticed in the dock area out there, you got cameras. What do you look at?" He wasn't sure. He really wasn't focused on that. And his focus was on, I must have bad people. Now, I'm not saying he doesn't have bad people. I'm saying we don't know if he has bad people. But if you don't give the people a chance to say, here's the analytical data so you can make decisions, you're never going to improve. And you're never going to have a better scheduling plan. So I offered him, for us to come in and get some data on the shipping area, just using the cameras he has. Mm-hmm. And he was elated. Yeah, I'm going to get back to you. I'm going to do that. I think that's what we bring. Mm-hmm. We can be your industrial engineer squared. Mm-hmm. You put the camera there, and we'll give you the data that's going to improve your decision making, that's going to give you more throughput and more efficiency on the factory floor. And if I would have had that back in 1970s when I was managing the factory, I would have been so excited because the people then were data driven, but they were data driven by a little stopwatch, mm-hmm. a little guy we send out to a trouble area, and he'd spend the week out there clicking. Then he'd spend another week with a little calculator, and then he'd come back and tell me, well, here's some opportunities, and half the time it was to make the guy work harder because he couldn't see the total picture of where the bottleneck was at. And that's what manufacturing is all about. And that's, to me, what engineering is all about. I mean, even when you're trying to fix a vehicle, what do? You keep breaking the problem down with information, smaller and smaller and smaller, till you find a piece you can fix. Okay, then you fix that part because you can fix it. then you do it again. That's what engineers do, and that's how engineers think. And I always felt that engineers thought deductively, and that was an advantage in manufacturing. Hey, I broke the problem down. I found the part we could fix. That makes the whole better. Now let's see what the next problem was that we could get a handle on and fix. Let me talk one more thing about car repair, because I just bought some of these devices. There's something called OBD2, and this is electronics, and there's a
Yeah.
plug
The diagnostic port. Yeah.
in all the new vehicles. And so,
Yeah.
unfortunately, there's not many of them that go across vehicle lines. So you have to buy one for your vehicle. And what it does the engineering job of telling you where the problem area is, kind of, right? Because it's going to give you a couple of different opportunities or lead you like in the right direction. And for instance, I'll give you the one I tried to fix myself. So I have a 911 Porsche, and of course the red light goes on the dash. It says brakes, and so I go, well, okay, what's wrong with the brakes? I push the brakes, they stop. I don't know. So it doesn't seem to be that. So I plug in this thing, and it comes back ABS sensor. All right, now there's an ABS sensor on every wheel, so you still don't know which wheel is which. You don't know if the sensor is bad or is the connector bad. You just know there's an ABS sensor, or maybe the ABS system in total is bad. So even with all this electronic information, you've broken the problem down some, but you haven't got to enough of a root cause to say, this is how I'm going to fix the problem. So at my age and at this time, I'm done. I take it to the shop, and it turned out to be the connector was rusted in the right front wheel. Okay. But hey, that's engineering. You break it down, you break it down, you break it down until you find something you could fix. And so we fixed the connector in the front wheel, and boom, the red light goes out, the problem solved, and we go forward. So that's I think, that what we're doing here at MOE gives such an advantage to manufacturing if it's utilized properly. And everybody wants, I think, at this day and age to be data driven, and you got to have the right data, and there's no better data than you're going to get visually.
Yeah, no, absolutely. As you're mentioning the example of root cause analysis and deductive capabilities, it's all data driven, right?
Yeah.
It's interesting that you still had the conversation with the stamping person, and we've had conversations with customers where they don't have data, but they make big decisions. And it's
Yeah.
probably because they don't know how to get the data, or they just don't have the ability to get the data, or there was just other things to do, right?
And I know I got it. Human nature, the I know I got it is, I need another truck doc. The people are bad. And that could be, but probably not. It's
Right.
probably something that we can do with the tools that we have.
Absolutely. And the camera data and the visual data is actually a strategic asset for companies that they don't know they have. It's because,
And well, they put it there for security. They probably
yeah,
put these cameras I saw yesterday so people don't steal things,
absolutely.
right?
And it's still good for that, but there's a lot more you can do with it, which I think, I love your analogy of the root cause analysis and the camera data, which go hand in hand. Again, the camera data could tell you that something happened. There are docks that are unoccupied, or percentages of utilization is low, but you
Or
still have to go in root cause. Yeah.
material wasn't staged in time, right?
Yeah.
Yeah. So, or
Yeah.
maybe the customer's at fault, because most of these now, because customer pickup, maybe the customer's at fault because they didn't give adequate notice. But we can't tie all this together.
Oh, it's really interesting. The idea of and a lot of manufacturing companies are looking at robotics, automation in plants, and without having overview of the plant, where I just don't know how they'll achieve that. I think having intelligence on the overview of the movement area, the material area, the production area is so crucial to have robots work well with people and with different parts, which may not be censored, right? Not everything can be
Yeah.
censored. So,
You know, I want to say one more thing. There was a book that was written probably 50 years ago now, and called The Goal.
mhm.
And it was all about throughput. And it was a story about throughput. And in fact, what I ended up doing when I was the plant manager of one of the plants, I bought the book for every supervisor, and I gave them the book as a gift. And then I wrote on the bottom of the gift, hey, I'm going to walk around the plant and quiz you on make sure you read the book. Because I thought the book was such good storytelling about breaking a bottleneck, increasing throughput was the name of the game. Now, they always didn't have the right data, but at least the thought process of that's how you get productivity, improving the flow and breaking the bottleneck. And there's always going to be a bottleneck. The issue is find it and then see what can be done to improve it. I mean, I'd recommend that book today. I think that, in fact, the author, who's probably passed by now because he was at least 30 years older than me, Goldrath was his name. When I bought, I think 50 books, I bought a case of books, and he called me. He said, nobody's ever bought a case of my books, you know. And what are you doing? What are you doing with them? And I told him I made every supervisor in the plant read it. And so he was all excited about that. And unfortunately, I don't think I ever had a chance to have time to meet him, but still the same thing. And having that data though provided for you because you already paid for it in the camera you installed is exactly what we do.
Mm-hmm.
And that's the strength of this company.
Absolutely. Yeah, it's very well put, Larry. As you look to the future, I was curious of, we have all these new systems that are coming in, and you have a lot of technology that's coming in. What do you think? I mean, if you were just to put your future hat on right now, let's assume that Moe does what it's supposed to do, and there's a lot of automation that comes into the US manufacturing space. Uh, do you have any thoughts on what the future is going to look like, maybe 10, 15 years from now in manufacturing?
Obviously, what I would say is repetitive jobs will be automated with not fixed automation, but flexible automation, so that, you know, as you have product changes, the automation isn't thrown away. And I think that's kind of something that's evolving today. AI has helped the integration into the machines has helped us provide the flexibility so that product changes become faster and less costly from a fixed cost perspective. I mean, in the past, I happened to live through the era where, you know, automation was brought to the factory floor, but it was 80% of the time fixed. So when the model changed or the product changed, you threw away the automation. So the whole thing became a very difficult justification financially to spend all this money and model changes. And you even think about the assembly line. You know, we used to shut down the assembly line for every 5 years. We have a major product change in the vehicle. And so we shut down the assembly line for 6 months to be able to get in there and put all the changes required. That's no longer necessary. And a lot of that is because of the flexibility you see. And so I think that kind of thing will continue. The other thing that's going to happen is what we wish to call production workers. Well, that drives the number of production workers down, but it also drives the number of maintenance people probably up. That's going to create an environment where they become engineer-like. And I think the era of white collar, blue collar is probably going to go away. And it's going to be, I mean, the evolution has probably already started. I mean, I had to wear a tie on the factory floor, right? Where we don't see anybody with a tie And I think back now is dangerous as hell. I could have got my thigh caught in equipment and then ripped my neck off, right? So that's gone. And now I think we're just going to have one level of work with various expertise in improvement of the operation and launch of products. So that I see is a difference in the future. And whether that minimizes the value of a degree or minimizes, I think there's be a blending, and it may not be as important, and you may have enough skill because you learned it on a cell phone to and look, I'm not the best person on a cell phone, so I need someone to help me with that. And 9 times out of 10, it didn't matter if they had a degree on that cell phone. They're able to. I ask usually my grandkids or you or Madhu to give me help me with my computer because I can't figure out what to do next to get it to work. So that I think is how manufacturing is going to develop. And I also think this that I lived through the era also of quest for low cost manufacturing. I located many facilities in China, many facilities in South America, Central America, Eastern Europe. That's gone. I think it's not going to be as important in the location of the factory because I think it might be just as important in the location of the demand. And the factory will follow. And that era that I lived through in the end of my career is probably changed.
Yeah, very interesting insights. I didn't look at it that way. That's actually quite thought-provoking. We have a single role as opposed to blue collar, white collar, where you just have machines and people managing the machines. So that's really just one role, if you think about it. And that person has multi-skills. Yeah, obviously, the operations of the machines as well as the operations of the plant.
Yeah.
So it's an interesting take, and I can totally see that. I mean, given the US is absolutely needs to automate, it seems to be the biggest solution right now to compete in the world. It seems like you need that skill set where you're able to use technologies like Vision AI and think about operations as the operator and make things work without actually having to touch things. You just have to make the machines do it. Very interesting. This was a great conversation, Larry, and I thank you for your time. And anything else you want to say, you can say it. Otherwise, you know.
Well, I think we have a great chance to provide the next era of improvement in manufacturing here with our technology at Moly. And I anything new starts slow, and I think we got momentum now. And there is just all the opportunity in the world for us to help lead the next generation of manufacturing. And I'm all supportive of us going forward and winning.
Sounds great. Thank you, Larry.
Right.
Thanks for your time. And
Yeah, sure.